To all of you joining me for this video, I am Mr. Ish. Thank you for joining me. We're looking here at additional clarification regarding extreme values. Everything I've talked about with regards to extreme values, global, local, absolute or relative, maxima or minima, I've talked in a more of a black or white perspective, but we're going to bring in some shades of gray over here. When we're looking at this depiction here in front of us, we have an interval a to b. We have two endpoints which are represented by the value on your function with regards to your interval points. We also have 4 of these critical points. Now, a good point of clarification is this. Endpoints can assume either an endpoint designation or an absolute designation. Rather, they can be absolute maximum or absolute minimum, whereas critical points can take both designations. They can be global or local. That is, they can be absolute or they can be relative. When we're looking here in terms of the range, the output at C2 generates what is called here an absolute maximum. But if you're looking at either points on either side of this C2, the neighboring points, it can also serve as a relative maximum. That is, it can be a global maximum and it can be a local maximum. When you're looking here at this critical point C3, the output that it generates right over here, it generates a lowest point over here. It can be an absolute minimum, but it can also be here a relative minimum. That is, we can say it can be a global minimum or local minimum, because in terms of the entire interval, this here is an absolute minimum, this here is an absolute maximum, but in terms of the neighboring points around this C3 and the neighboring points around C2, we can have the local or the relative designation come into play. When we're looking here at C1, you know we're looking here at a relative minimum. At C4, we're seeing a relative maximum. The endpoints are nothing more than an endpoint. So to sum it up, C1 turns out to be a relative minimum, C2 is an absolute maximum and a relative maximum, C3 is an absolute minimum and a relative minimum, C4 is just a relative maximum, and A and B are just endpoints. In the remainder of this video, we will just look at a good example and we'll bring these additional clarification into perspective. We will end with this function right here, f of x equals sine x from minus pi over 2 to pi minus 90 to 180. You know, if you were asked to determine all the extreme values, you can start here with a derivative of this, because the derivative of this, when equaling a 0, it can either give you a situation where there is no critical point or there is a critical point. When you take this cosine x and you equal it to 0, you know x is equal to the arc cosine of the 0, and you know you get a pi over 2. Pi over 2 designates some sort of a critical point here where something is happening. If you do the second order derivative of this, you have a minus sine x. When you take this value right over here and you put it right here in this second order derivative, you're doing exactly what I'm showing you. You're placing pi over 2 right here, you're getting a minus sign of a pi over 2, and you end up getting nothing here other than a minus 1. What does that tell you? The fact that you're getting not this minus 1, I'm looking here at the sign. The fact that you're getting a minus, we're looking here at a bit of a relative or a local maximum phenomenon going on. So it's either a relative maximum or you can call it a local maximum, but we're seeing 3 points over here, one of which is your critical point you've determined right here, a critical point. The other 2 are your endpoints. If we list them in numerical order from small to large, we have a minus pi over 2, then we have a pi over 2, and then we have a pi, and we input these into your original function. What is our original function right here? When you do minus pi over 2 and you take the sine of it, you get a minus 1. When you do pi over 2 and you do a sine of that, you get a positive 1. When you do a pi and the sine of that, you get a 0. From the appearance of what we're seeing here, we're seeing here an absolute maximum, we're seeing an absolute minimum. Let's do some labeling over here. Absolute maximum, global maximum, absolute minimum, global minimum. We can put here relative maximum and we can put here a relative minimum and see what comes out in terms of all of this. We're seeing an absolute maximum here occur at pi over 2. When x is equal to a pi over 2, we have an absolute maximum value here of a positive 1. When x is a minus pi over 2, we're seeing here a absolute minimum, and that value is a minus 1. We're seeing also here now, in terms of clarification, a relative maximum. Within the neighboring points of this right here, we actually have a relative maximum which shares a designation as an absolute maximum. We see a relative maximum here at x is equal to pi over 2, and that occurs at a value of a positive 1. Relative minimum, we see no designation of that. If we were to graph this out, what would you have? In terms of a sign, you have a minus pi over 2, you have a positive pi over 2, and then you have a pi. We have a positive 1, we have a minus 1. Let's graph it out. Sine is always a minus 1 at minus pi over 2, it's a 0 at a 0, it's a 1 over here, and it's a 0 here, so our curve would look something like this. It's a little bit distorted, but we can work with that. It looks quite distorted to me, but let's just keep it as is. Let's come back here. We have an absolute maximum at x equals pi over 2. This right here is pi over 2, that's pi minus pi over 2 here. At this point, we have an absolute maximum and we have a relative maximum. At x is equal to minus pi over 2, at this point right here, an end point ends up being an absolute minimum, or you can say a global minimum. This point right here ends up being designated nothing. It's not anything other than just an endpoint. So out of the 3 points we have, one endpoint is nothing in terms of designation. One of the internal points is a critical point. It ends up being an absolute maximum and a relative maximum. The third point is an endpoint. It ends up being designated an absolute minimum or a global minimum. So you see how everything has played here. Not every point has to be designated as something, but do keep in mind endpoints are designated as just endpoints or some sort of an absolute extreme. Internal critical points can be designated as both absolute or as relative extreme values. So that's a good clarification that you should be aware of. But remember, we had 3 values over here, 2 endpoints, 1 critical point, and we had 3 designations. One single value ended up sharing 2 designations, another endpoint had a single designation, and another endpoint had no designation. Thank you for watching. Have a nice day. Bye.